Hello, this is Nitin Desai. Today we are going to present one seminar which will help to understand the embedded programming. This is the basic embed program. Whatever you are observing is the online compiler of embed, and it is free of cost. Just you create one account and you can use it freely. Here we have set one targeted device such as embed LPC 11U24. You can select your requirement or your specification. This is the basic program. Aim of this program is to blink the single LED. Means in this program we are going to execute one loop, that is while loop, for infinite number of times. So it will give the blinking LED. In this example, we have mentioned one keyword, that is digital out. This keyword is present or declared in library called as mbed.h. This library is included in almost all the in all the embed programming example or embed programming. Why it is needed? Because in this library we have mentioned different classes, that is analog in, analog out, bus in, bus out, bus in, bus out, like that. These are all classes are used to help help to reduce the code size. This digital out keyword is used to make this LED one as a output. This is the syntax of embedded programming. In this main we have written one while function, and we are blinking the LED at 0 and 1 as shown in program. I will show one practical example of the same. This is the single LED, and this is the embedded board, and it is blinking continuously after equal interval of time. I'll show pin diagram of it's a pin diagram of this embed board. It has four inbuilt LEDs as shown in figure, and these are the all pins which can act as a GPIO, that is general purpose input output. We can save this program and we can compile. Click on compile. After doing compilation, it will generate one file which is of extension .bin. Save it and copy it on embed board and just reset the embed board. It will give the result. Second program here we are going to represent is blink all LED one by one. In the same example, here again we are declaring all four LEDs as a digital out. So, and we are sending one to each LED at a time, shown in program. We will implement all this program as shown in video. This is the embed board, and all LEDs are blinking one at a time, and it is running for infinite number of times. Again we have third one example. This is the third example, and which has aim of blink all LED at a time using bus out. Bus out again is a class which collect the output and send it to the output pins collectively. Here we have mentioned my LED as a collective name of all LEDs, that is LED 1, LED 2, LED 3, LED 4, and we are giving the value to this name, so it will send the respective values to respective pins. Here I have mentioned 15, which is in decimal. Why it is in 15? Why it is 15? Because when we give one to the LED 1, it explore. Similarly, for LED 2 and LED 3 and LED 4 means we have to give 4 ones to glow all the LEDs at a time. 4 ones in binary means F in hex and 15 in decimal, and that's why I have mentioned as 15 here. You can use hex, that is 0F, or 4 1 in binary. Here we have this wait function, which is again inbuilt function which produces the delay of 0.5 seconds. Here I will show the output of this program. And this is the mbed board, and these 4 LEDs blinking at a time, blinking all at a time. This is one of the application of using the 4 LEDs. In this we are representing all the 16 numbers, that is 0 to 15. That is, we are creating one 4-bit counter. It is as shown in program. It's same, just we are using bus out as a keyword, making all LEDs as a output and sending the collective result to the this pin. In this for loop is used, and it is initialized to 0, and value should be less than 16, means we are giving the 0 to 15 values to the LEDs. Output of this program will be this is the embed board, and we are observing that it is showing the numbers from 0 to 15. After that we are going to explain one code which has both combination of output pin as well as input pin. Pin 21 to 22 will act as the input, and pin 24 and 25 will act as the output. Separate LEDs are used to show the output. Digital is again class mentioned in mbed.h. Here one more important thing is how to read the data from the input pins. Here the syntax is used, that input one dot read. It takes the data from the input pin and store in any variable declared in main, and this variable value can be given to the output LED as shown in program. We can show the output of this program on embed board. Actual output is depends upon the what type of input we are providing, what type of value we are providing at a pin 21 and 22. We will show it on embed board itself. This is the embed board, and this is the two resistor. One of the terminal of resistor is connected to the pin number 21 and 22, and other end of this two resistors are connected to ground or VCC. It depends upon the what type of input we are going to give. Now in this example, uh, we have given one of one of the RS2 terminal to the VCC. That's why one LED was glowing. And now we have given both LEDs, both the input of both the terminals of resistor to the VCC. That's why both LEDs are glowing. here. My last one example is the uh, combination of serial window as in timer. What is means serial window? Serial window generally used to represent the data which is taken in the form in the serial form. For this purpose, uh, we use term. This is the terminal window, serial window. After opening this, we will get this pop-up window. In this, click on the serial and select the particular port. After connecting the embed board, you will come to know which type of port is there. Accordingly, you select it and click on OK. Then after running the code on embed board, you will get output on serial window. One more important thing is how to send the data on serial window. For this, we have created one object, that is PC here, and we are using the format like that, pc.print. When it prints something on serial window, we can use the data format, that is %d, to represent the values on serial window. One more thing is the how to use the timer. I have used created one object of timer, and it is there is used one function, that is start and stop. This function find out how much time required for instruction within that start and stop. And key dot read gives the what is the time required to execute that block of code. This is the function used to create the factorial of given number. Here we are going to show output of this program. This is the embed board, and again we are going to do setting for Terra terminal, and this pop-up window is there, and we have selected here serial, and then we are selecting the respective COM code, and then we are resetting the code on embed board. It is showing the output like that. Output of this program is the what is the time required to execute that block of code and factorial of number. This is the main aim of our today's presentation. In this presentation, we use different uh, serial function, timer function, how to use serial window, and how to send the data on serial window, how to calculate the time required to execute one instruction. Basically, on high level language, we don't have any option to calculate how much time is required to execute any particular instruction, but however it is possible in assembly language. So to calculate such time period, we can use this timer concept, and basically it is useful for real-time systems where time is important. How much time required to execute any one instruction is required to build the system. So we can use this timer function to calculate the time. And here we learn how to make the pins as input, how to make the pin as a output, how to read the data from the input pins. All the functions we learn. Thank you very much.